What if everything you've ever experienced is just one thread in a vast tapestry of infinite possibilities? What if the reality you know is merely one version of countless others, each unfolding in ways that defy imagination? Today, we're diving into the mind-bending world of alternate realities, a concept that stretches the boundaries of science, philosophy, and even our understanding of existence itself. This isn't just about science fiction or wild speculation. It's about exploring ideas that challenge the very foundation of what we think we know. In this video, we'll unravel 20 astonishing concepts that will make you question the nature of reality itself. From parallel universes to paradoxical theories, from the quantum realm to the farthest edges of speculative thought, we're embarking on a journey that will leave you wondering, what if the world you see is just the tip of the iceberg? Get ready to explore theories that will stretch your mind, challenge your assumptions, and maybe even change the way you see everything around you. Let's begin. Picture this, an endless expanse of universes, each one a unique bubble floating in an infinite cosmic sea. This is the multiverse, a mind-bending idea that suggests our universe is just one of countless others, each with its own set of rules, laws, and even realities. It's not just science fiction, it's a theory rooted in the cutting-edge fields of quantum mechanics and cosmology. Scientists propose that at the quantum level, every possible outcome of an event actually happens, but in a different universe. This is the many worlds interpretation, a concept that suggests every decision you make, every path you take, spawns a new universe where the alternative choice played out. Think about it, somewhere out there in a parallel reality, there's a version of you who made a different choice at a key moment in life. What would that version of you be like? Would they be happier, more successful, or living a completely different existence? The multiverse theory goes even further, suggesting that these alternate universes might not just differ in outcomes but in the very fabric of reality itself. In some, gravity might be weaker or stronger. In others, the speed of light could be different, or atoms might not even exist. The possibilities are as infinite as the multiverse itself. It's a staggering thought, one that challenges our understanding of existence and pushes the boundaries of what we consider possible. But how does this tie into the bigger picture? If the multiverse is real, it could explain some of the biggest mysteries in science, like why our universe seems so finely tuned for life. Maybe it's not that our universe is special, it's just one of many, and we happen to be in the one where the conditions are just right. This idea opens up a whole new realm of questions. Are there realities where life evolved in ways we can't even imagine? Could there be universes where time flows backward, or where the laws of physics are so alien that they defy comprehension? As we explore these ideas, it's impossible not to wonder about the nature of reality itself. Are we living in just one thread of an infinite cosmic tapestry? And if so, what does that mean for our choices, our lives, and our understanding of existence? These questions don't just challenge science, they challenge us to think bigger, to imagine a reality far beyond the limits of our own universe. And speaking of limits, the multiverse isn't the only concept that stretches our understanding of reality. What if these universes aren't just separate bubbles but are connected in ways we can't yet comprehend? That brings us to the next intriguing idea, branching realities where every decision creates a new path, weaving an intricate web of alternate timelines. But more on that in a moment. What if every choice you've ever made, whether it's what to eat for breakfast or whether to take that job offer, created an entirely new universe? This is the mind-bending idea behind parallel universes and branching timelines. Picture this. Every decision you make sends reality down a new path, like a train switching tracks, creating a version of the world where you took the other option. It's not just science fiction, it's a concept rooted in chaos theory and the famous butterfly effect, where even the tiniest action can ripple out and lead to vastly different outcomes. One moment you're deciding to grab an umbrella before leaving the house, and in another universe you didn't. And that small choice might have changed the course of your entire day or even your life. Now think about the movie Sliding Doors, where a single moment catching or missing a train splits the protagonist's life into two completely different realities. In one, she finds love and happiness. In the other, her life takes a darker turn. It's a perfect example of how one small event can create parallel timelines, each with its own unique story. But here's where it gets even wilder. If every decision creates a new universe, then there could be infinite versions of you out there, living out every possible outcome of every choice you've ever faced. One version of you might be a world-famous musician, while another might be living a quiet life in a small town. The possibilities are endless. And if that's not enough to make your head spin, consider this. What if these parallel universes aren't completely separate? What if they somehow interact with each other? Could there be moments where the boundaries between realities blur, allowing us to catch glimpses of these alternate versions of ourselves? It's a fascinating thought, and it leads us to the next big question. How might these realities collide or overlap? But that's a story for the next concept. For now, just think about the infinite yous out there, living lives you'll never know, but might have if even one tiny detail had been different. What if everything around you, the people, the stars, even the laws of physics, was nothing more than lines of code in an unimaginably advanced computer simulation? This is the core of the simulation hypothesis, a mind-bending idea that suggests our reality might not be as real as we think. The concept isn't just the stuff of science fiction, it's rooted in serious philosophical debate. Thinkers like Nick Bostrom have argued that if a civilization could create simulations indistinguishable from reality, it's statistically likely that we're living in one. Even tech visionaries like Elon Musk have weighed in, famously stating that the odds we're not in a simulation are 1 in billions. To put it simply, imagine a video game so advanced that the characters inside it have no idea they're part of a program. They think, feel, and make choices completely unaware of the player controlling their world. Now scale that up to an entire universe. If a higher civilization, perhaps 1 million of years more advanced than ours, could create such a simulation, why wouldn't they? And if they did, how could we ever tell the difference between their creation and what we call reality? This idea isn't just theoretical, it raises profound questions about the nature of existence. For instance, if we're in a simulation, what happens to concepts like free will or the meaning of life? Could the rules of physics be rewritten by the programmers of this simulation? And most intriguingly, how would you even know if you were living in one? Some scientists have even suggested experiments to test this hypothesis, like searching for glitches in the fabric of reality, tiny errors that might hint at the code beneath it all. As we explore this concept, it naturally leads us to another fascinating question. What is consciousness, and how does it fit into this simulation framework? If our minds are part of the program, does that mean our sense of self is an illusion? Or could consciousness itself be the key to unlocking the truth about our reality? These are the kinds of questions that make the simulation hypothesis more than just a thought experiment. It's a doorway into rethinking everything we think we know about existence. What if the reality we experience isn't as fixed as it seems? What if our own consciousness plays a role in shaping it? This idea isn't just science fiction, it's a concept that's been explored in both physics and philosophy. Theories like quantum consciousness and the observer effect suggest that our minds might have a far more active role in the fabric of reality than we've ever imagined. At the quantum level, particles behave differently when they're being observed, almost as if our attention influences their state. Could this mean that our perception is somehow intertwined with the very nature of existence? Take meditation, for example. Through focused awareness, meditators often report experiencing altered states of consciousness realities that feel just as vivid and real as our waking world. Similarly, lucid dreaming offers a fascinating glimpse into how the mind can construct entire worlds, complete with sights, sounds, and even physical sensations. These experiences hint at the incredible power of consciousness to create or influence alternate realities, even if only temporarily. But what if this phenomenon goes beyond the individual? Some theories propose that reality itself might be a projection of our collective consciousness. Imagine billions of minds, each contributing to a shared experience of the universe. This idea suggests that the world we see around us isn't just an objective truth, but a collaborative creation, a kind of cosmic story we're all writing together. As we ponder the mysteries of consciousness, it's impossible not to wonder how time fits into this equation. If our minds can shape reality, does time flow as linearly as we think? Or is it another layer of perception waiting to be unraveled? The answers might lie in the next concept, where we'll explore the enigmatic relationship between time and alternate realities. What if time isn't the rigid, unchanging force we've always believed it to be? Imagine it instead as a dimension, something that bends, stretches, and even folds, opening doors to alternate realities. This idea isn't just science fiction. It's rooted in Einstein's theory of relativity, which tells us that time is far more flexible than we realize. Think about time dilation, where time moves slower for someone traveling near the speed of light compared to someone standing still. This phenomenon suggests that time isn't universal but relative, and that small change in perspective could mean infinite possibilities for alternate realities. Take the movie Interstellar, for instance. In the film, astronauts experience time differently depending on their proximity to a massive black hole. What feels like minutes for them turns out to be years back on Earth. This isn't just dramatic storytelling, it's based on real scientific principles. Time dilation hints at a universe where time itself can be manipulated, creating branching paths of existence. What if every decision you make splits time into a new reality? One where your choices lead to entirely different outcomes, but let's go even further. What about closed time-like curves? These are theoretical loops in space-time where an object or person could travel back in time and return to the same point. It's like a cosmic Möbius strip, twisting time back onto itself. If such curves exist, they could allow for alternate realities where past events are rewritten, creating a cascade of new timelines. Picture this: what if you could go back and change one pivotal moment in your life? Would you? And if you did, would that new reality be better, worse, or just different? This leads us to the tantalizing idea of infinite timelines. If time is as malleable as space, then every decision, every action could spawn a new reality. Somewhere out there, alternate versions of you are living out the consequences of choices you never made. It's a dizzying thought, but it opens up endless possibilities for exploration. And that brings us to our next concept, the multiverse, where infinite timelines coexist, each one a unique universe with its own rules, its own history, and its own version of you. What if every choice you've ever made, every path you've taken or left behind exists somewhere, not just as a fleeting moment, but as an infinite loop playing out across countless realities? This is the mind-bending idea behind infinite timelines and eternal recurrence. At its core, the concept suggests that every possible version of reality is happening all at once, and not just once, but over and over again in an endless cycle. It's a theory that challenges our understanding of time, choice, and even the meaning of our existence. Philosophers have wrestled with this idea for centuries. Friedrich Nietzsche introduced the concept of eternal recurrence, proposing that the universe repeats itself in an infinite loop. Every joy, every sorrow, every triumph, and every regret, all of it will happen again and again, exactly as it did before. Imagine living your life only to find yourself back at the beginning, reliving every moment without any memory of the previous cycle. It's a thought that's both awe-inspiring and deeply unsettling. Would you find comfort in the familiarity, or would the repetition make every decision feel heavier, knowing it would echo across eternity? Literature has also explored this idea in fascinating ways. Think of stories like the Groundhog Day effect, where characters are trapped in a repeating day, forced to confront their choices and grow from them. Or consider the multiverse narratives in science fiction, where every decision spawns a new reality, each one equally valid and real. These stories aren't just entertaining, they're thought experiments that challenge us to reflect on our own lives. If you knew your life would repeat forever, would you live it differently? Would you take more risks, cherish the small moments, or strive to leave a lasting impact? This concept also raises questions about the boundaries of reality. If infinite timelines exist, how do we define what's real? Is one version of you more true than another, or are all versions equally valid? The idea pushes us to rethink not just our understanding of time, but also our sense of self. Who are we, really, if every possible version of us exists somewhere in the multiverse? As we explore these questions, we're drawn closer to the next fascinating idea, the boundaries of reality itself. How far can we stretch our understanding of existence before it breaks? And what lies beyond those boundaries? The answers might just redefine everything we think we know about the universe and ourselves. What if everything we see, touch, and experience in our three-dimensional world is nothing more than a shadow, a projection from a two-dimensional surface? This is the mind-bending idea at the heart of the holographic principle. It proposes that the universe we perceive as three-dimensional might actually be encoded on a two-dimensional boundary, like a cosmic hologram. Think of it this way: just as a holographic image on a flat surface can create the illusion of depth, our entire reality might be a projection from a flat, two-dimensional plane. The roots of this theory lie in the study of black holes. Physicists discovered that the information about matter falling into a black hole isn't lost but is instead encoded on its event horizon, the boundary surrounding the black hole. This led to the idea that all the information in a three-dimensional space could, in theory, be stored on its two-dimensional boundary. String theory, a framework attempting to unify all fundamental forces, further supports this idea by suggesting that the fabric of reality might be fundamentally lower dimensional than we perceive. To make this concept more tangible, consider how holograms work. A flat piece of film can produce a three-dimensional image when illuminated correctly. In the same way, the holographic principle suggests that the universe's complexity might be encoded on a simpler, lower-dimensional surface. Even optical illusions, where a flat image tricks our brain into seeing depth, can help us grasp how our perception of reality might be an elaborate projection. The implications of the holographic principle are staggering. It challenges our understanding of space, time, and the nature of reality itself. If our universe is a projection, what does that mean for the flow of time? Could time itself be an illusion emerging from this two-dimensional code? And what about the idea of higher dimensions? Could the holographic principle be a clue to unlocking the mysteries of dimensions beyond our perception? Speaking of dimensions, this brings us to an even more intriguing question. If our reality is a projection from a lower dimensional surface, what lies beyond it? Could there be higher dimensions we're not equipped to perceive, playing a hidden role in the cosmic dance of the universe? This idea bridges us perfectly into our next concept, where we'll explore the tantalizing possibility of higher dimensions and what they might mean for the structure of reality. Now, let's stretch our minds even further and step into the realm of higher dimensions. What if the universe we know is just a tiny slice of something much larger, something that exists in dimensions we can't even perceive? This idea isn't just science fiction, it's rooted in some of the most cutting-edge theories in physics, like string theory and M-theory. These theories suggest that our universe might be part of a multiverse, a vast network of realities stacked like pages in a book, each existing in dimensions beyond the three we experience every day. To grasp this, think about how a two-dimensional being living on a flat plane would perceive our three-dimensional world. To them, we'd seem like impossible, shifting shapes as we move through their flat reality. In the same way, higher dimensions could contain entire realities that are completely hidden from us, vibrating just out of reach. String theory, for instance, proposes that the fundamental building blocks of the universe aren't particles but tiny, vibrating strings. These strings exist in up to 10 or even 11 dimensions, depending on the theory, and their interactions could give rise to countless alternate realities. Mathematics and geometry give us a way to visualize this mind-bending idea. Imagine a hypercube, a four-dimensional version of a cube. We can't fully see or experience it, but we can describe it mathematically. Just as a cube unfolds into 6 squares, a hypercube unfolds into 8 cubes in three-dimensional space. It's a glimpse into how higher dimensions might operate, vast, complex, and utterly beyond our everyday experience. So, what would it be like to experience a fourth spatial dimension? Would we see objects from all sides at once? Would time itself behave differently? These questions don't just challenge our imagination, they push the boundaries of what we think is possible. And as we ponder these ideas, we're led to another frontier of science that's equally mysterious and profound, the strange, unpredictable world of quantum mechanics. Here, the rules of reality seem to bend and twist, offering yet another layer of intrigue to the puzzle of alternate realities. Now, let's take a step into the bizarre and fascinating world of quantum superposition, a concept that feels like it's straight out of science fiction but is very much grounded in scientific reality. At its core, quantum superposition is the idea that particles, like electrons or photons, can exist in multiple states at once until they're observed or measured. Think of it like a coin spinning in mid-air. While it's spinning, it's not just heads or tails, it's both simultaneously. Only when it lands does it choose one state. This strange behavior isn't just a quirk of tiny particles. It might hold the key to understanding alternate realities. To make this idea more relatable, let's revisit one of the most famous thought experiments in physics, Schrödinger's cat. Picture a cat inside a sealed box with a device that has a 50% chance of releasing poison. According to quantum mechanics, until you open the box and observe the cat, it exists in a superposition of being both alive and dead at the same time. It's only when you look inside that the cat state collapses into one outcome. Now, imagine this principle scaled up to the universe. If particles can exist in multiple states, could entire realities exist in parallel, each representing a different outcome of quantum events? It's a mind-bending idea that suggests our reality might just be one of countless possibilities. But what could this mean for our understanding of existence? If superposition implies that every possible outcome of a quantum event exists somewhere, then alternate realities might not just be theoretical. They could be real, branching off every time a decision is made or an event occurs. This idea ties directly into the many worlds interpretation of quantum mechanics, which proposes that every possible outcome of a quantum measurement actually happens, each in its own separate universe. Suddenly, the idea of alternate realities isn't just a plot device for sci-fi stories, it's a serious scientific hypothesis. And here's where things get even stranger. Superposition isn't the only quantum phenomenon that hints at the existence of alternate realities. Enter quantum entanglement, a phenomenon where particles become linked in such a way that the state of one instantly influences the state of another, no matter how far apart they are. It's as if these particles are communicating faster than the speed of light, defying our classical understanding of space and time. Could entanglement be a bridge between alternate realities, connecting them in ways we're only beginning to comprehend? The answers might lie in the next concept we're about to explore. What if the fabric of reality isn't just a single, isolated sheet, but a vast, interconnected web? This brings us to the 10th mind-bending concept, quantum entanglement, and the possibility that alternate realities might be linked in ways we're only beginning to understand. At the heart of this idea is quantum entanglement, a phenomenon so strange that even Albert Einstein famously called it spooky action at a distance. Here's how it works. When two particles become entangled, they share a connection that defies the limits of space and time. Change the state of one particle, and the other instantly responds, no matter how far apart they are. It's as if they're communicating faster than the speed of light, a concept that challenges our understanding of the universe. But what does this have to do with alternate realities? Some scientists speculate that entanglement might not just be a connection between particles. It could be a bridge between entire realities. Imagine a multiverse where every decision you make spawns a new timeline, a new version of reality. What if entangled particles are somehow tied to these branching paths, acting as messengers between them? Experiments like the famous double-slit test, where particles seem to choose their behavior based on observation, hint at a deeper layer of interconnectedness. Could it be that alternate realities are constantly influencing each other through these quantum links? It's a tantalizing thought, one that pushes the boundaries of what we consider possible. So, what does this mean for us? If alternate realities are entangled, could they be communicating or even overlapping in ways we can't yet detect? And if so, how might that shape our understanding of existence itself? These questions take us to the edge of what science can currently explain, but they also open the door to incredible possibilities. As we ponder the implications of quantum entanglement, another cosmic mystery beckons: black holes. These enigmatic objects where gravity bends space and time to their will might hold even more clues about the nature of reality and its many layers. What if the most destructive force in the universe, black holes, could actually be the key to unlocking entirely new worlds? It's a mind-bending idea, but one that some of the brightest minds in physics have seriously considered. Black holes, those regions of space where gravity is so intense that not even light can escape, might not just be cosmic vacuum cleaners. Instead, they could serve as gateways to alternate realities, a concept rooted in theories like the Einstein-Rosen bridge, often referred to as a wormhole. Imagine this: deep within a black hole, the laws of physics as we know them break down. Time and space warp in ways that are almost impossible to comprehend. Some scientists speculate that the crushing gravitational forces and extreme conditions inside a black hole might create a tunnel, a bridge, connecting our universe to another. This isn't just science fiction. The Einstein-Rosen bridge, first proposed in the 1930s, suggests that black holes could theoretically link two distant points in spacetime, or even two entirely separate universes. It's like a cosmic shortcut, but one so extreme that it bends the very fabric of reality. Of course, the idea of traveling through a black hole to another universe comes with its own set of challenges. The tidal forces near a black hole's event horizon, the point of no return, would stretch anything or anyone into a spaghetti-like strand long before reaching the other side. And yet, the possibility that black holes could be portals to alternate realities has captured the imaginations of both scientists and storytellers alike. Think about movies like Interstellar, where black holes are depicted as gateways to other dimensions, or novels that explore the idea of parallel universes born from these cosmic anomalies. But what would these alternate realities look like? Could they be mirror images of our own universe or something entirely alien? The implications are staggering. If black holes truly are gateways, they could revolutionize our understanding of space travel, offering a way to traverse unimaginable distances in the blink of an eye. They might even hold clues to the very nature of existence itself, challenging our perception of reality and the universe's boundaries. Now, if black holes are the entrance to these alternate realities, what about the exit? Enter the concept of white holes, the theoretical opposite of black holes. While black holes pull everything in, white holes are thought to spew matter and energy outward, potentially serving as the other end of a wormhole. It's a fascinating idea, one that ties the mysteries of black holes to the even more enigmatic white holes, creating a cosmic loop that could redefine how we see the universe. But that's a story for the next concept. What if our universe wasn't the first or the only one? Enter the fascinating concept of white holes, the theoretical counterparts to black holes. While black holes are known for their immense gravitational pull, trapping everything, including light, white holes are thought to do the exact opposite. Instead of pulling matter in, they spew it out, releasing energy and matter into the cosmos. It's as if they're cosmic fountains, gushing out the building blocks of reality itself. But here's where it gets even more intriguing. Some scientists speculate that white holes could be the birthplaces of entirely new universes or alternate realities. Imagine a white hole as a cosmic gate, not to destruction but to creation, a doorway to a brand new existence. This idea isn't just science fiction. In the realm of theoretical physics, white holes emerge as possible solutions to Einstein's equations of general relativity. They're like the reverse side of a black hole's coin, offering a glimpse into how the fabric of spacetime might work in ways we're only beginning to understand. For instance, some theories suggest that a black hole in one universe could be connected to a white hole in another, forming a bridge, a wormhole between two separate realities. This raises a tantalizing question. Could our own universe have been born from a white hole in another cosmos? It's a thought that stretches the imagination and challenges our understanding of existence itself. But white holes aren't just about alternate realities, they also hint at the deeper mysteries of the cosmos. If they exist, they could help explain some of the most perplexing phenomena in the universe, like the origins of dark energy or the nature of the Big Bang itself. Some cosmologists even suggest that the Big Bang might have been a colossal white hole event, spewing out the matter and energy that formed everything we see today. It's a theory that ties the birth of our universe to the very fabric of spacetime, offering a fresh perspective on how it all began. As we ponder these ideas, it's hard not to wonder, what lies beyond the horizon of a white hole? Could there be an infinite number of universes, each born from its own cosmic fountain? And if so, what does that mean for our place in the grand scheme of things? These questions lead us to the next great mystery, dark matter. Just as white holes challenge our understanding of creation, dark matter pushes us to rethink the very structure of the universe itself. What invisible forces are at work, shaping the cosmos in ways we can't yet fully comprehend? The journey into the unknown continues. What if the universe is hiding something vast, invisible, and utterly mysterious? Enter dark matter, one of the most enigmatic aspects of our cosmos. Scientists estimate that dark matter makes up about 27% of the universe, yet we can't see it, touch it, or even detect it directly. So, what if this invisible substance isn't just a cosmic placeholder but a gateway to hidden or alternate realities? Here's the fascinating part. Dark matter doesn't interact with light or electromagnetic forces, which is why it remains invisible to us. But its presence is undeniable. We see its effects in the way galaxies rotate, the way light bends around massive objects, and even in the large-scale structure of the universe. It's like a ghostly hand shaping the cosmos from the shadows. Could this ghostly hand belong to another reality, one that exists parallel to our own but remains just out of reach? Take galaxy clusters, for example. These colossal structures are held together by gravity, but the math doesn't add up unless we account for dark matter. Without it, galaxies would fly apart, This suggests that something we can't see is providing the extra gravitational pull needed to keep everything in place. Could this something be the gravitational footprint of another dimension or a hidden universe brushing up against ours? The implications are staggering. If dark matter is evidence of alternate realities, it could completely redefine our understanding of existence. It could mean that our universe is just one layer of a much larger, interconnected multiverse. And while dark matter pulls galaxies together, there's another cosmic mystery at play: dark energy. This mysterious force is causing the universe to expand at an accelerating rate, pushing galaxies apart. Together, dark matter and dark energy might be the yin and yang of hidden realities, one pulling, the other pushing, both shaping the fabric of existence in ways we're only beginning to comprehend. So, as we ponder the invisible threads of dark matter weaving through the cosmos, let's turn our attention to its counterpart, dark energy, the force that might hold the key to understanding not just our universe, but the very nature of reality itself. Now, let's turn our attention to one of the most mysterious forces in the cosmos, dark energy. This invisible, enigmatic energy is not just a passive observer in the universe, it's the driving force behind the accelerated expansion of everything we know. Imagine the universe as a balloon constantly inflating, but instead of slowing down, it's speeding up. That's the effect of dark energy, pushing galaxies farther apart at an ever-increasing rate. But here's where things get even more fascinating. What if this expansion isn't just stretching space, but also creating entirely new realities or dimensions? The idea isn't as far-fetched as it sounds. Cosmologists and theoretical physicists have long speculated that the fabric of space-time isn't static. As the universe expands, the very rules that govern reality could shift, giving rise to regions where physics operates differently. Picture this: pockets of space where gravity behaves in ways we can't yet comprehend, or dimensions folded into existence by the sheer force of expansion. It's like the universe is constantly rewriting its own rulebook, and dark energy is the pen. Now, let's take a moment to ponder something truly mind-bending. If the universe is expanding, what lies beyond its edge? Is there a boundary, or does reality stretch infinitely? These questions lead us to the edge of human understanding, where science meets the unknown. And while we may not have all the answers yet, the journey to uncovering them is nothing short of thrilling. This brings us to another intriguing possibility: wormholes. Often depicted in science fiction as shortcuts through space-time, wormholes are theorized to connect distant parts of the universe or even link entirely different realities. Could these cosmic tunnels be a byproduct of dark energy's influence on the fabric of space? Or perhaps they're gateways to those newly formed dimensions we just discussed? Either way, the interplay between dark energy, expansion, and wormholes opens up a universe of possibilities, literally. What if the universe had secret tunnels, hidden shortcuts that could whisk you across unimaginable distances, or even into entirely different realities? This is the tantalizing idea behind wormholes, theoretical bridges through space-time that could connect distant parts of the cosmos or even alternate dimensions. In the realm of theoretical physics, wormholes are often described as folds in the fabric of space-time, creating a tunnel-like passage between 2 points that would otherwise be impossibly far apart. Imagine crumpling a piece of paper and poking a hole through it. That's essentially how a wormhole could work, bending the rules of space and time to make the impossible seem achievable. Science fiction has long embraced this concept, bringing it to life in ways that spark our imagination. Take the classic film Contact, where a wormhole becomes humanity's gateway to an alien civilization. It's a breathtaking portrayal of how these cosmic shortcuts might function, blending scientific curiosity with the thrill of the unknown. But while wormholes make for compelling storytelling, the reality of traversing one is fraught with challenges. For starters, the extreme gravitational forces inside a wormhole would likely crush anything attempting to pass through. even if we could stabilize one, perhaps with exotic matter or advanced technology, the journey would remain a perilous gamble with no guarantee of survival or arrival at the intended destination. Yet the possibilities are too intriguing to ignore. If wormholes could connect not just distant regions of space but alternate realities, they might offer a way to explore parallel universes where history unfolded differently, or where the laws of physics themselves are subtly altered. Picture stepping through a wormhole and finding yourself in a world where dinosaurs never went extinct or where humanity never evolved. The implications are staggering, both scientifically and philosophically. But here's where things get even more mind-bending. What if these wormholes didn't just bridge space and alternate realities, but also time? This leads us to the next concept, time loops. If wormholes can manipulate space-time, could they also create closed loops where events repeat endlessly, trapping travelers in an infinite cycle? The idea of time loops opens up a whole new layer of possibilities and paradoxes that challenge our understanding of reality itself. Have you ever imagined living the same day over and over again? This is the essence of time loops, a fascinating concept where events repeat endlessly, trapping individuals in a never-ending cycle of the same experiences. Think about it. What if every morning you woke up to the same sunrise, the same conversations, and the same outcomes, no matter what you tried to change? This idea isn't just science fiction. It's a mind-bending possibility that challenges our understanding of time and reality. Time loops suggest that certain moments could exist in a closed cycle, creating alternate realities where the same events unfold repeatedly. Imagine a version of you living the same day for decades, learning, adapting, and evolving, but always resetting to the starting point. Movies like Groundhog Day brilliantly capture this concept, showing how a single day can become a playground for self-discovery, frustration, and even transformation. But what if this wasn't just a story? What if time loops were real? Could they serve as gateways to parallel universes, or would they simply trap us in a relentless echo of the same reality? Now, let's take it a step further. What would you do if you found yourself stuck in a time loop? Would you try to break free, or would you embrace the repetition, using it to master skills, solve problems, or even explore the limits of your own mind? This question isn't just hypothetical, it's a window into how we perceive time, choice, and the very fabric of our existence. Time loops force us to confront the idea that reality might not be as linear as we think, and that alternate versions of our lives could be playing out in ways we can't even imagine. But what if time loops aren't just about repeating the same events? What if they're connected to something even more mysterious, like the idea of retrocausality, where the future could influence the past? This is where things get truly intriguing. Stay with me as we explore how the past, present, and future might intertwine in ways that defy our everyday understanding of time. What if the future could reach back and shape the past? This isn't just a plot twist from a sci-fi movie, it's a real scientific idea called retrocausality. At its core, retrocausality flips our traditional understanding of cause and effect on its head. Instead of the past influencing the future, it suggests that future events can, in some way, influence what happens in the past. It's a mind-bending concept that challenges everything we think we know about time and reality. To get a sense of how this might work, let's look at quantum mechanics. In certain experiments, particles seem to know what's going to happen to them in the future, adjusting their behavior accordingly. For instance, in a delayed choice experiment, a photon can appear to decide whether it behaved like a particle or a wave retroactively, based on how it's observed later. It's as if the future is reaching back and rewriting the rules of what already happened. This isn't just a quirky observation, it raises profound questions about the nature of time itself. Now, imagine what this could mean for alternate realities. If the future can influence the past, could there be multiple timelines where those influences play out differently? And what does this mean for free will? If our future choices are somehow shaping our past, are we truly making decisions, or are those decisions already woven into the fabric of time? It's a paradox that blurs the line between determinism and freedom, leaving us to wonder just how much control we really have over our lives. But let's take this one step further. If retrocausality is possible, it opens the door to even stranger possibilities, like the idea of Boltzmann brains. These hypothetical entities are self-aware structures that could arise randomly from the chaos of the universe, complete with false memories of a past that never actually happened. It's a bizarre thought, but it ties into the idea that the future, and even the present, might not be as fixed as we assume. And that's where our journey takes us next, into the strange and speculative world of Boltzmann brains. What if everything you know about your existence, your memories, your sense of self, even the world around you, wasn't real? What if you were just a fleeting moment of consciousness born out of chaos? This is the strange and unsettling idea behind the Boltzmann brain hypothesis. Named after the physicist Ludwig Boltzmann, this concept suggests that in a universe governed by entropy and randomness, self-aware entities could spontaneously form, complete with false memories and perceptions of reality. To understand this, let's think about entropy, the measure of disorder in a system. Over time, entropy tends to increase, leading to chaos. But in a vast, infinite universe, even the tiniest pockets of order can emerge by sheer chance. A Boltzmann brain is one such pocket, a fully formed, self-aware mind that arises randomly, perhaps for just a fraction of a second before dissolving back into chaos. Imagine waking up thinking you've lived a full life, only to realize it was all an illusion created by a random fluctuation in the cosmos. Now, here's where it gets even stranger. If Boltzmann brains are possible, then the odds suggest there could be far more of these isolated, random minds than there are real, continuous beings like us. In fact, some physicists argue that it's more likely you're a Boltzmann brain right now, experiencing a brief moment of false reality, than a person living in a stable, consistent universe. It's a bizarre and almost existential thought. Could everything you're experiencing be nothing more than a cosmic accident? This idea also raises questions about the nature of reality itself. If random, isolated consciousnesses can exist, then what does that mean for the universe? Could there be countless other realities, each one a fleeting, chaotic creation? It's a concept that blurs the line between science and philosophy, challenging our understanding of existence. So, let's take a moment to reflect. If the Boltzmann brain hypothesis is true, how would you ever know? Could you be one? Or is this just another mind-bending thought experiment that pushes the boundaries of what we think is possible? As we ponder these questions, another intriguing phenomenon comes to mind: the Mandela Effect. This is the collective misremembering of events or details, like people recalling Nelson Mandela dying in prison in the 1980s, even though he lived until 2013. Could this be evidence of alternate realities colliding, or is it simply a quirk of human memory? Either way, it's another fascinating layer to the mystery of existence. Have you ever been absolutely certain about a memory, only to find out that it never happened the way you remember it? This strange phenomenon is at the heart of what's known as the Mandela Effect. Named after Nelson Mandela, many people vividly recall his death occurring in the 1980s while he was still in prison. Except, of course, he actually passed away in 2013. This isn't just a case of misremembering. Large groups of people share these alternate memories, leading some to wonder if these discrepancies could be evidence of alternate realities overlapping with our own. Think about it. Could these shared false memories be glimpses into parallel universes where events unfolded differently? For instance, some people swear they remember the children's book series being called The Berenstain Bears, but it's actually spelled Berenstain. Or take the famous line from Star Wars. Many recall Darth Vader saying, "Luke, I am your father," when the actual line is, "No, I am your father." These aren't just random mistakes, they're consistent across thousands, even millions of people. So, what's really going on here? Some theories suggest that the Mandela Effect might be a sign of the quantum multiverse at work. In this view, our reality isn't the only one, there are countless others, each with its own version of events. Occasionally, these realities might overlap or interact, causing fragments of alternate timelines to seep into our collective memory. It's as if the universe itself is glitching, giving us fleeting glimpses of what might have been or what could still be. The Mandela Effect raises fascinating questions about the nature of memory and reality. Could it be that we're not just misremembering, but actually tapping into something much bigger? Have you ever experienced a moment where your memory of an event or detail didn't align with the facts? If so, you might have brushed up against the edges of an alternate reality without even realizing it. As we explore this idea further, it's impossible not to wonder about the quantum multiverse. If the Mandela Effect is evidence of parallel realities, what else might be out there? What other versions of ourselves or our world could exist just beyond the veil of our perception? The answers might lie in the next concept we're about to dive into, where the quantum multiverse takes center stage. Picture this: every decision you've ever made, every path you've taken, and every road you've left untraveled. What if all of those possibilities exist simultaneously? This is the heart of the quantum multiverse, a theory that suggests every possible outcome of every event creates its own separate reality. It's not just one universe we're talking about here, but an infinite number of them, each branching out like the limbs of an ever-growing tree. From the moment you woke up this morning to the very second you pressed play on this video, countless versions of you are living out every conceivable scenario in parallel universes. Sounds mind-bending, doesn't it? Let's break it down. In quantum mechanics, particles don't behave in predictable ways. Instead, they exist in a state of probability, where multiple outcomes are possible until observed. The famous Schrödinger's cat thought experiment illustrates this perfectly. Until you open the box, the cat is both alive and dead simultaneously. The quantum multiverse takes this idea and applies it to the entire cosmos. Every time a quantum event occurs, every particle interaction, every decision made, the universe splits, creating a new reality for each possible outcome. It's as if the universe itself is constantly rewriting its story, branching off into infinite narratives. Now, consider the implications of this. Every time you flip a coin, there's a universe where it lands heads, another where it lands tails, and even one where it hovers in midair, defying gravity. Every choice you make, from what you eat for breakfast to the career you pursue, spawns an entirely new reality. What does that mean for free will? Are we truly making choices, or are we just experiencing one thread of an infinite tapestry of possibilities? It's a question that blurs the line between science and philosophy, challenging our understanding of reality itself. To make this even more tangible, think about cosmology. Our observable universe is vast, but it's just one bubble in a cosmic foam of multiverses. Some of these universes might have slightly different physical laws. Gravity could be stronger, light could move faster, or time itself might flow differently. In one universe, Earth might not even exist. In another, you might be the ruler of a galactic empire. The quantum multiverse ties together many of the concepts we've explored in this video: alternate timelines, parallel worlds, and the idea that reality is far stranger and more expansive than we can comprehend. So, what does the quantum multiverse mean for you? If every choice you make creates a new reality, does that empower you or overwhelm you? Does it make your decisions feel more significant, knowing that somewhere out there, another version of you is living a completely different life? Or does it make you question the very nature of existence? These are the kinds of questions the quantum multiverse invites us to ponder, pushing the boundaries of our imagination and challenging us to think beyond the limits of our own reality. As we wrap up this exploration of alternate realities, it's worth reflecting on how these ideas reshape our understanding of the universe and ourselves. The quantum multiverse isn't just a scientific theory. It's a lens through which we can view the infinite possibilities of existence. It reminds us that reality is far more complex, interconnected, and mysterious than we often assume. And as we step back into our own world, perhaps we can carry with us a sense of wonder, knowing that somewhere out there, another version of this story is unfolding in ways we can only begin to imagine.